Over the past year, as more and more people have started working from home, they've become more dependent on services like Zoom. And so you've seen a lot more videos come up on YouTube about the best possible setup for work from home, whether it be the best camera or the best lighting or the best way to position your laptop. But this video is bound to be quite a bit different than those. A couple of years ago, in 2019 to be specific, MKBHD released a video where he basically talked about downloading and uploading one of his YouTube videos 1,000 times to see what the quality before and after was. In order to store the massive amount of videos that sit on YouTube's platform, along with all the new videos uploaded each day, and in order to get those videos over to your phone, tablet, or laptop in a reasonable time, YouTube needs to compress the videos to be a more digestible size, as shown in Marquez's video. He also discusses an intuitive common compression technique that he references in this video. Now, I'm not an expert, but I'll go through it really quickly. You see, essentially, in order to compress a video, which is just a combination of a lot of pictures, this compression algorithm basically looks for instances where two subsequent frames of a video look very, very similar in certain areas. For example, up here, I have not gestured or made any changes to this area in some time. And so as a result, in order to compress a video with this region in it, it can basically take this same picture over and over again as long as there's not substantial change in each frame. The compression algorithm will then leave parts of the video alone that have more frequent change. So for example, if I'm waving my hand right here, there's more change, and so this will not be able to be compressed as much as something up here. Now, basically, what this means for video chatting is in order to reduce the amount of data that's being sent across the network and shrink it down to as small a size as possible, all video chatting applications have this same sort of compression algorithm baked in. So all of this came together in an idea for me. How do I efficiently structure my video so that I can basically have only the regions that I want to be compressed, and those that I don't. So specifically, I don't want my mouth and my face to be significantly compressed when I'm talking. I don't want my hands to be compressed when I'm gesturing. But I would care less about my shirt, for example, being compressed. So how do I make it easier on the algorithm in order to compress the things that I want to be compressed? So what came to mind specifically is with clothing. So this shirt, for example, is a quite uniform color with no specific patterns. And so my hypothesis was that this would allow for the most compression of this area, hopefully giving more hypothetical bandwidth or headroom for the other areas like my face that is more likely to change. Whereas with more complex, colorful, and patterned shirts, there'd be more changes, and therefore the compression algorithm couldn't compress that area, basically taking up a larger portion of my bandwidth. Now, we'll have to see how this works in practice. Let me talk first about the setup in order to record this. I set up two computers, one we'll call the sender and the other the receiver. The sender was a laptop with a webcam connected to it, where I basically would do my video conference. Whereas the receiver was only receiving the video feed from a Zoom call. On both computers, I specifically had a network monitor set up to see how much send and received data were going across the network, specifically for the Zoom application. First, I needed some sort of baseline, so I set up my camera, pressed record, and then walked away from the scene. As the camera was recording a blank wall with no changes, this should be the baseline of essentially a picture being sent across the network, so should be the most compressible, and therefore it should take up the least possible data. The results of this baseline were about 240 bytes per second, or about 1.9 megabits per second of total upload speed. Now notably, the upload speed on both the sender and the download speed on the receiver were pretty close to in parity, at least through Zoom, and so there wasn't really any big difference. The second baseline that we might reference is me standing relatively still in my gray shirt, leaning against the wall, without a lot of movement. In this position, I was getting around 335,000 bytes per second, or 2.7 megabits per second, which is 40% larger than our other baseline. In order to simulate a more natural movement that someone might have while on a video chat, I tried swaying slightly from side to side. Now, obviously, this isn't what people do when they're on a video chat, but there is enough movement that a compression algorithm has to adjust for. And so my swaying side to side was a consistent way for me to try this across several different outfits. While swaying side to side in this plain gray shirt, I was getting about 3.14 megabits per second. And so then we'll use any other clothing to compare to that. So now let's talk about once I put on more complex, more detailed, more patterned clothing. The next outfit that I tried on was a black and gray plaid button down, which has a little bit more complexity that will hopefully drive the algorithm to have more trouble to compress the image, therefore driving more megabits per second across the network. And the result? Yeah, a little bit more. I got 3.16 megabits per second compared to the 3.14 from before, so only 0.02 of a megabit per second higher, which is not really significant. But after some time of stabilizing between the two, it was quite consistently higher than the plain gray shirt. So a difference. I then tried a few more shirts with a teal blue plaid checked shirt that has a relatively small pattern, a plain white dress shirt with a pocket on the front, and a white plaid checked shirt with very, very small, almost college graphing paper style pattern. And the results were, generally, the ones with patterns required more bandwidth, but not to a huge extent. The shirt that actually took the most bandwidth was the teal blue one, being 4% over my baseline of swaying back and forth in this plain gray shirt. And then just to make sure that my theory wasn't completely broken, I basically just played a very, very crazy video in front of the camera to see if the bandwidth would go up, and it did. It went up a massive 25 to 27%, which is quite substantial and shows that the video wasn't able to compress, or Zoom wasn't able to compress that video nearly as much. And so the theory is correct. It's just the amount of change that takes place because of the change of clothing you might have is only a few percentage points, which is not going to make a big difference in whether your video quality is any good. But then I had one more idea. You see, there's been several instances I've been on calls with colleagues that have had ceiling fans spinning in their background. And as the ceiling fans spin, it seems like their bandwidth goes down, or at least the quality goes down somewhat. And I'm not sure if those two are correlated. And so I wanted to see specifically if you have moving objects in your picture, therefore objects that are unable to be compressed by the compression algorithm, does your video quality go down for the same reason? Or do you have to have more bandwidth? And so what I did was, I don't have a ceiling fan, but I have a standing fan, and I put it side by side with me in one of these shots to see whether when it was on, it would take up significantly more bandwidth. Nope, it's basically the same story. I was able to get a few percentage points more than when I was standing with a turned off fan next to me, but having a fan next to me, at least this one, didn't make a significant difference in the quality of the video as far as I could see, or the bandwidth that was being taken up. So what's the bottom line? Well, despite the fact that in all the videos where I was wearing more complex pattern clothing, the amount of bandwidth went up, it really didn't make enough of a difference in order for me to change the type of clothing that I wore on Zoom calls. Obviously, the biggest things that contribute to video quality are the positioning of your camera, the lighting, and that sort of stuff. All those things mentioned in the other videos. I'd be really interested to see if the same thing happened for YouTube videos, where changing my outfit changed the size of the YouTube video, but I doubt it'd make a big difference. I did still enjoy today in order learning something new about compression. And if you want to learn more about the way that videos are compressed, check out some of the videos that I have linked in the description. Thank you for watching again. If you want to see more ridiculous experiments just like this, be sure to get subscribed because I've got more on the way. Thank you for watching, and I'll catch you in the next one.